Lesson 3 is all about surface area. So it's saying if generally it's talking about a 3D shape. Let's say you were to wrap a box. We've got a present that is a rectangular prism, saying what is the surface, the area of all of the surfaces in total. So this surface, the side surface, the top surface, as well as the surfaces that are at the back and the bottom that you can't see. So it's what is the total area that the surface takes up. Okay, so as you can see, we've got a little animation playing at the side. Now this animation comes from this link, which is in your booklets. Okay, so it shows that the surface area of a rectangular prism starts as a rectangular prism and then folds into 1, 2, 3, 4, 5, 6 rectangular surfaces. So there are 6 surfaces. They are all rectangles. The formula to calculate a rectangle is area equals base times height. Next, we've got a triangular prism and it's unfolding. So if you want to view this yourself and play around with it, click on or type that link into your internet browser. But yeah, so this shows a triangular prism has 1, 2 triangular faces and 1, 2, 3 rectangular faces. So there's 5 surfaces altogether. We've got 2 triangles. Hang on, my handwriting is atrocious at this. Let's try again. 2 triangles, 3 rectangles in our formula. So we've got area of a triangle, as we know, is half the base times the height, and the area of a rectangle is just base times height. Okay, lastly we've got a cylinder, and the animation shows that a cylinder can be unfolded into a rectangle and 2 circles. So the net becomes 1 rectangle, 2 circles. So the number of surfaces there are 3. We've got 2 circles, 1 that's nice spelled rectangle. Let's try that again. Rectangle, that's better. And our formula for a circle, we know, well, hang on, let's write that properly. The area of a circle equals pi r squared, and the area of a rectangle equals base times height. Now, if we have a think for this one about what the area of the rectangle will be, this here, this is your height. It's your height of your rectangle, it's also the height of your prism. Now the width of your rectangle, or the base of your rectangle from here across, that is given by the circumference of your circle. Because when this folds onto the circle, it wraps around the circle, making the base of your rectangle the circumference of your circle, which is given by 2 pi r. So the formula for the surface area of a cylinder, we have 2 circles, so 2 lots of pi r squared plus the area of a rectangle, which is base times height. The base is 2 pi r times h. So this is the surface area. 2 pi r squared plus 2 pi r h. Okay, so we're going to calculate the surface area of each 3D solid. First one is a rectangular prism. We have 6 faces. Now, a prism is a prism because, or one of the definitions of a prism is that the opposite faces are equal. So the face here, this little red face, is the same as this face at the back. They are equal. So we have 2, well, we're going to label each face 1, 2, 3. So we have 2 of each because, I'll use my highlighter, this yellow face here is the face at the back. The green face at the front here is the same as, if we were to, hang on, trying to make this clear, but it's hard to draw 3D on a 2D picture. So that green face I've just colored in is the same as this green face at the back. Okay, now last one, the purple face at the top, well, let's make it blue actually, the blue face at the top is the same as this blue space down the bottom. So we had 2 yellows, 2 greens, 2 reds. So 2 yellows, 2 greens, 2 blues. And I'll just color in the first of each. Hope that's making sense. So each face matches. Anyway, to find the area of each face, we're going to use our area formula. Now remember, the area of a rectangle is simply given by base times height. So we'll do area 1 equals 6 times 5, which is 30. Area 2 equals 11 times 6, which is 66. Area 3 equals 11 times 5, which is 55. So in total, the surface area, we've got 2 lots of area 1 plus 2 lots of area 2 plus 2 lots of area 3. So 2 lots of 30 plus 2 lots of 66, it looks like a times, plus 2 lots of 55. I'll just pop that in my calculator and let's calculate the surface area. So when we add that all up, we get 302. Now because this is surface area, even though it's on a 3D shape, it's a flat area that we're calculating. So we're calculating, remember, the area of the net, like this, which is a flat area. So it's in centimeters squared is our units. All right, shape B. So for shape B, we've got 5 faces altogether, but 2 of them are the same because this at the front, what color should I use? Orange. This triangle at the front here is the same as this triangle at the back. And all of our rectangles are different. So let's label our sides. Oh, in pen, here we go. 1, and we'll label our, 2 is our diagonal at the back, 3 is our diagonal at the side, and 4 is also our rectangle at the back, a rectangle at the side, and 4 is our rectangle at the bottom. And now the rectangle at the back is also, let me try words one more time. The triangle at the back is the same as a triangle at the front. So you have two area 1s, and then an area 2, an area 3, and an area 4. And I'll re-highlight those as I do them so we know what we're talking about. So to find area 1, which is a triangle, we're going to do half times the base, which is 4, times the height, which is 6. So half of 4 is 2, and 2 6s are 12. So area 1 is 12, and we have 2 of those. All right, now area 2, I made the diagonal rectangle over here. Okay, so the one sloping off the front. Sorry about my wriggly pen. That is area 2. Okay, so to calculate area 2, we need to do base times height because it is a rectangle. So the base is this length along here, which we know is 8. And the height is this diagonal length here, which we don't actually know. We haven't been given that length. However, we can find it, can't we? Because if we look at this triangle across the front, we have a right angle triangle with 2 sides. We know how to find the third side. To find this third side, we're going to use Pythagoras. All right, so we'll do that over the side here. So c squared equals a squared plus b squared. We know it's c squared because we're finding the longest side. C squared equals 6 squared plus 4 squared. C equals the square root of 6 squared plus 4 squared. What is the square root of 6 squared plus 4 squared? Well, it's 7.211102551. Now, we do not want to leave that, or we don't want to round that. Okay, so what we're going to do is we're just going to leave that as the square root of 52. Okay, and we will round at the end, because if we round halfway through a question before we times, we're going to stuff something up. So, root 52. Area 2 is 8 times root 52, which we're just going to write as 8 root 52. Now, thinking back to our third days, we can simplify that, because that equals 8 times root of 4 times 13, which equals 8 root 4 times root 13, which is 8 times 2 times 13, or root 13, which is 16 root 13. I know I stepped that out the really long way, but I'm just reminding because we haven't done that in a little while. So 16 root 13, okay, is area 2. All right, area 3 is next. Remember, area 3 is this rectangle up the back here. Now we've got both those measurements. We've got a 6 and an 8. So area 3, actually, we'll go back up here. And I'll draw a line separating these two questions. Area 3 equals 6 times 8. And we know 6 8s are 48. And last one, area 4. So area 4 is the, I'll make it purple, rectangle at the bottom. That's area 4. So we've got a base length of 4 and a height of 8. So it's 4 times 8. And 4 8s are 32. So now to find the surface area of the total everything, we need to add it all together. So surface area equals, I'm just going to add down so I don't run out of space. 12 plus 48 plus 16 root 13 plus 32. Now, because we've got a root 13 in there, let's just put it in the calculator. We don't need to leave it in exact form. So we can just put it in the calculator just like that. If we were leaving it in an exact form, we'd leave 16 root 13. Oopsies. There we go. 16 root 13 as a add-on to make it a separate like term, but we're just going to round to 2 decimal places. And we get 149.688. So that's going to round to 0.69 centimeters squared. All right, again, surface area equals 149.69 centimeters squared. All right, last one for this example, but there's 2 examples after this. We've got a cylinder. We want to find the surface area of it. So we've got 1, 2 circles, and then we've got the rectangle here that when we fold it out, it'll be a big long rectangle. So if we were to lay that out, the net would look like this. Circle, circle, and then big rectangle in the middle. Okay, so to find the surface area, first we're going to do the circles as area 1. Oh, hang on, I just realized something. I made a mistake in the last question because I've only added up 4 lengths here and there are 5 faces. So we are missing an extra area 1 because we have 2 area 1s. So that's not the answer. We need to also add on another 12. So we get 161.69 centimeters squared. Whoopsie doopsies. All right, so back to our cylinder. We've got 2 area 1s. We're going to do that first. So area 1 equals pi r squared. Now we don't have the radius, we've been given the diameter is 10. So remember the radius is just half the diameter. The radius goes from the middle to the edge, which is 5 centimeters. So pi times 5 squared. Pi times 5 squared is, well, actually, let's leave it in exact form until the end. It'll be 25 pi, and we won't round until the end. Okay, next, we've got a rectangle. So the rectangle, remember we talked about this top length here is the same length as the circumference of the circle. So that is given by 2 pi r. So area 2 is calculated doing 2 pi r, that's our base, times the height of the rectangle, which we'll call h. So area 2 equals 2 times pi times 5 times the height, which is 12. So 2 times 5 is 10. 10 lots of 12 is 120 pi. So if we were to add all of our areas up, surface area equals, we've got 2 lots of area 1, so 25 pi plus 25 pi plus an area 2, which is 120 pi. So altogether, we have 50 pi and then 170 pi. So that's an exact form. But if we want to calculate it to the 2 decimal places, 170 times pi, we get 534.070, which will round to 534.07 centimeters or meters? Centimeters again. Centimeters squared. And that is the surface area of our cylinder. All right, example 2. Find the height of a cylinder when its surface area is 134 meters squared and its radius is 4 centimeters. Now, we are going to pretend that that says meters, okay? Because we're not worried about different units, that's going to just be too much. We want them to match. So we've got meters squared and meters. So please cross out your centimeter, make them all the same. Okay, so our surface area formula, if we think about it, we've got two circles, so 2 lots of pi r squared, plus a rectangle, which is made up by base times height. Our base is our radius, not our radius, our circumference, 2 pi r, times the height. So that's our surface area formula for a cylinder. All right, now let's sub in the values that we know. We know that the surface area is 134. So instead of surface area, we're going to write 134 equals 2 pi r, oh no, we know the radius, sorry. 2 pi, now radius says here is 4 meters. So instead of r, we're going to write times 4 squared plus 2 pi times 4 times h. All right, so we're going to try to solve this and without rounding until the very, very end. So we're going to just leave pi as pi till the very last step. So first thing we're going to do is we're going to get this part of the term by itself. To do that, we're going to minus all of this, because that's just being plussed onto the 2 pi times 4 times h. So to get rid of it, we're going to minus 2 pi r squared, or 2 pi times 4 squared. So we get 134 minus 2 pi times 16. Actually, I kind of want to simplify it. Let's simplify it first. That would be nicer. (134) equals 2 pi times 16 plus, now 2 times 4 is 8 pi h. Now we can also combine these. 2 times 16 is 32. So 134 equals 32 pi plus 8 pi h. This will make life easier. All right, now we're going to do what we just did. We're going to take away all of that from both sides. So we get 134 minus 32 pi. Now remember, they're not like terms, so we can't actually subtract them. We need to leave them as separate terms. Equals 8 pi h. Now we just want h, so we're going to divide everything by 8 pi. And we're going to then have h equals 134 minus 32 pi over 8 pi. If we put that in the calculator, we'll find the height of the cylinder. So we should get, I'll write it over here, h equals 1.331, so we're on to 1.33 meters, not just meters because it's a vertical height. Now, to check that it's right, we just need to sub the height and the radius into the equation for surface area and see if we get, see if we get 134 meters squared. So we have 2 times pi times the radius, which is 4 squared, plus 2 times pi times 4 times 1.33. Let's see if we get 134. Well, I get the surface area equals 133.957, which is close to 134, but as you can see, because we've rounded our answer, this is not exact, but that's approximately correct. Let's go into our last example for the lesson. Example 3, and how we can see here, it's got a little tricky note next to it, so let's be nice and careful as we do this one. Find the radius of a cylinder which has a surface area of 234 centimeters squared and a height of 7 centimeters. Okay, so start the same. We write our formula. Surface area is 2 circles, so 2 lots of pi r squared plus the area of the rectangle. So it's 2 pi r times h. But this is the base of the rectangle, which is the same as the circumference of the circle. Okay, let's sub in all the values that we know. So the surface area has been given to us is 234, and the height is 7. So we get 234 equals 2 times pi times the radius squared plus 2 times pi times the radius times the height, which is 7. All right, now let's simplify as much as we can. 234 equals, well, we may as well write that all together because there's no other numbers we can times, plus 2 pi r 7. We can multiply the 2 by the 7. We get 14 pi r. Okay, so now we may be noticing that this is a little bit tricky, but we can move the 234 over here by minusing 234. You hopefully soon will start to notice what I notice. 2 pi r squared plus 14 pi r minus 234 equals 0. What do we notice? We've got an r squared, an r, and a number. Does it kind of look like this? If it was x's instead of r's, ax squared plus bx plus c equals 0. Remember that is a quadratic. We've created a quadratic in terms of r. Oh, hang on, my r disappeared. There should be an r there. 2 pi r squared plus 14 pi r minus 234 equals 0. So we're going to use the quadratic formula to solve this. Quadratic formula. Now let's write it down to remember. Quadratic formula equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that is r. So the radius equals negative b plus or minus the square root of b squared minus 4ac over 2a. So let's figure out what each term is going to be. Our a term is 2 pi. Our b term is 14 pi. And our c is negative 234. So let's sub all of the values into our quadratic formula. So we're going to calculate r by doing negative b, so negative 14 pi, plus or minus the square root of b squared, so 14 pi all squared, minus 4 times a, so times 2 pi times c, which is negative 234, over 2a, which is 2 lots of 2 pi. Now, I know that looks like a lot, however, pi is just a number, so we can solve this by just putting it in the calculator. Now remember, you will put this in the calculator twice because the first time you will use the plus and the second time you will use the minus. So when we use our plus, we get the radius equals 3.535 to 3 decimal places. Now if we were to use the minus, now I'd recommend don't clear your calculator, just arrow back through and put a minus in. If we were to use the minus, we would get negative 10.535. Now, only answer that we can accept is positive 3.535 because it's a distance. Remember, distances can't be negative. So the radius equals 3.535 centimeters, approximately, to the nearest 3 decimal places. And that is our answer. If you want to check it, sub this back up into our formula. Given the height is 7, and if you get 234, you're doing a good job.